Hello, hello, and welcome back to the official podcast of the Bison Regional Science Fair, BRSF STEMcasts. Today we've got an episode full of super useful science fair tips that I'm sure will help everybody up their science fair game. And we've also got a guest who I'm sure can definitely tell us all about it, Dr. Cory Nykiforuk. Hello, and welcome to the podcast.
Thanks for having me.
Once again, thank you so much for being here. Now, Dr. Nykiforuk, besides being a director of research across many scientific fields, particularly biotechnology, has served as the chief judge at the Bison Regional Science Fair. So, I thought it would make sense for our topic today to be what science fair judges look for in a project. So, Dr. Nykiforuk, let's start by identifying what I'd say is the most common structure for a science fair project. There's the abstract, the introduction, followed by the background research or literature review. There's research questions and the hypothesis. Then we get into the interesting stuff, the variables and methodology, results, conclusions, and of course, the work cited. So let's begin with the abstract. What exactly do science fair judges look for?
Well, typically, even within the research community, the abstract is a very high level synopsis of what the experiment or what the innovation or even what the study performed was, and some of your key findings. It's almost like the tagline or a headline that you might use for an article or something of that nature, just to grab people's attention and really give them a quick overview
Mm-hmm.
of what you did and what you found. It's really the key information. Yeah.
Right. So I've noticed sometimes people don't exactly know how to write one, as in, it sometimes ends up becoming like a second introduction almost. So I would say just remember the project is a brief synopsis of the entire project. It's not exactly an introduction, not exactly a repetition of your findings. I mean, they should both be in there, but just in summarized form. They shouldn't
Yeah.
exactly, yeah.
No, I would just add, when you think about it, that's actually a good analogy, is that you don't want to essentially repeat what you have in your
Mm-hmm.
introduction, because you're not essentially introducing a topic. You, essentially you're getting to the real key points of what you were trying to find, what you found, what it means.
Right.
Yeah.
So moving on, what do you think should be the most important things you should mention in your introduction or your background research and your literature review?
Well, I think for the introduction, it's your opportunity to set the stage,
Mm-hmm.
right? So, it depends on the type of program or sorry, the type of project that you're presenting, but really you're trying to provide the reader or the scientific judge a little sense of context.
Right.
So, typically an introduction is going to have a background to the topic.
Mm-hmm.
An introduction should typically include, what's known in the area or the field at
Mm-hmm.
the point in time. And again, you can still end your introduction with what you are presenting as your hypothesis,
Right.
and what you are attempting to show. And maybe you can even add in what you expected, or actually what you found, and what your conclusion is, coming out of the introduction.
I see.
And then you're going to use the rest of the body of your presentation to actually show that.
Okay. So, leading into research questions and hypotheses, what do you think are the most common mistakes you find in these?
I think keeping making it too complex.
Mm-hmm.
Just keep it very simple. Hypotheses are essentially you're trying to combine observations or things that you've noticed,
Mm-hmm.
and determining if essentially an independent factor, or an independent variable in
Mm-hmm.
this case for an experimental type of presentation, is going to have an effect. And really, that's the nuts and bolts of the scientific method. For innovation, a hypothesis might be a little bit different, or it might have a
Mm-hmm.
little bit different feel, essentially because you're bringing ideas together to synthesize a newer idea.
Right.
So I think that's essentially what you would use to
Mm-hmm.
form that type of statement of what you're trying to show.
Mm-hmm.
And study, again, study is essentially, this is what is known, and what you're trying to find out.
Mm-hmm. So, I just want to point out that something I usually find within research questions, or something that I actually used to do, is that my research questions were always answerable by the word yes or no. And I think that's actually a pretty big mistake because we want to be starting our questions off with like how or does. For example, um, one might say, do plants grow faster when you water them? This is, of course, answerable by yes. So I think a better way of saying that or asking that would be, how does frequent watering affect growth of a plant?
That's a good point. Yeah, you don't want your conclusions already kind of
Mm-hmm.
preset in your actual hypothetical question.
Right.
Hmm.
So moving on into variables and methodology, what do you think science fair judges look for most in this section?
Again, I think in the context of the three different types of presentations, experimentally, you are controlling every variable as much as you can, except the one independent variable that
Mm-hmm.
you're trying to measure and quantify. So that sounds easier said than done sometimes. If like you
Right.
said, the frequency of watering a plant. Well,
Mm-hmm.
yeah, you can water a plant 5 times a day. But if you water 5 times a day, are you doing it 5 times in the morning, or are you doing it throughout the day?
Right.
Do you do it at 10, 12, 2,
Mm-hmm.
4 o'clock at the same time every day, the same? So you're just trying to keep those conditions the same every single time that you're applying
Right.
your one variable. So that's important because you know students have busy lives too, and
Mm-hmm.
they forget maybe days that they did things. And all you're doing then is if you find you made a mistake, don't try and start fudging the results. You
Right.
simply note that that's what happened.
Mm-hmm.
That's the case, and then you're trying to get everything back on track.
Right. So.
um yeah, I mean, innovations are a little bit different, I guess, because you got a little bit more flexibility and freedom, right?
Mm-hmm.
Like, again, you're just trying to explain um exactly what you did,
Right.
to test and look at your prototype. So be it. And for studies, I'm not as it's maybe it's not as clear as how do you control that. But then I think maybe what you want to do is demonstrate that you use really good reference materials,
Mm-hmm.
that you just didn't go to perhaps the internet and essentially regurgitate what you found, but you're
Right.
actually thinking about it and synthesizing a
Mm-hmm.
certain way. Yeah.
So how would one go about writing a methodology?
I think the simplest formula is to say exactly what you did, when you did it, how you did it.
Mm-hmm.
It's really, if the best way I think of thinking of a methodology is, if I wrote something down and I gave it to three of my friends, could they go and do the exact same thing I did?
Aha. Okay. That's very
And if
interesting.
and it's, maybe that's a good test that you could do, right? You say,
Mm-hmm.
this is my methodology. If I gave this to you, could you repeat it?
Right.
And if your friend's saying, well, I don't know if I could do this, or you actually watch them do it and they're doing everything wrong, everything's out of step or
Mm-hmm.
sequence, then you know you haven't written your methodology quite right. But it
Okay.
just takes a little practice.
I see. So, moving into the results, what kind of advice would you give for somebody who's just done their science fair and is now recording, or done their experiment and is now recording their results?
Again, I think you just want to be clear in what your observations were.
Mm-hmm.
Typically, when we go and list results, we want to list the results and what our key findings are again. Whether that's pulling information from a table,
Mm-hmm.
or I guess in a science fair, you don't have as much room. So you might just actually be using in your results section, this is my table, make sure it's clear and
Mm-hmm.
understandable. If you're using figures or graphs, make sure that your axes are labeled so people aren't
Right.
asking, well, what's this on the bottom, or what's your independent variable, what's your dependent variable.
Mm-hmm.
So and just so that you understand exactly what your data means, I
Mm-hmm.
guess, for an experimental type of presentation.
Right. And drawing back to presenting the results, if you are presenting them in a graph, of course, make sure to get the X and Y right, which one is dependent, which one is independent. But I would also say just present your results without any
Again,
bias.
your citations, yeah,
Yeah.
just look for explaining that so people understand. One of the things is really to enable your colleagues, in this case your fellow students,
Mm-hmm.
to, if they wanted to find out the same results or they wanted to find out the same information, they could go to the same sources and come to the same ideas or conclusions that you came to.
Right. So,
Mm-hmm.
moving on to the conclusions, of course. What is the best way to present the conclusions?
I would say fairly brief and short. Get right to the point. Again, I think and a lot of people do this. There's a tendency to kind of rehash even the introduction. You don't have to do that. It's just simply go straight to how you interpret your results, how you interpret your findings. What does it really mean to you?
Mm-hmm.
And the conclusion obviously should be supported by all the data and results that you just presented.
Mm-hmm.
So again, in going into your presentation, I know you guys are have a good curriculum going at the school, but it's good to get your friends reading them too, right?
Mm-hmm.
And ask them what they think, what they thought. Does it make sense to them? It should just be clear.
Mm-hmm.
Mm-hmm.
So, moving on to the works cited. What is the most common problem you see in the works cited section?
When I'm thinking back to the science fair, it's sometimes a very short list.
Mm-hmm.
Sometimes it's very few places they've gone to,
right,
look for information. So a single source, I mean, you should use more than a single source all the time. If you're trying to show something that's already known, you're going to have a lot of sources.
Right.
And there's nothing wrong with that, I think, because if you're showing something that even someone else has shown, what you're doing is your results are corroborating their same conclusions or results as well. So I think, that's just a typical maybe shortcoming that you might see in some presentations, that the amount of researching the program before they even designed or set up their experiments or prototype or whatever it might be, was maybe a little short-ended or short-sighted at the front, and that's why it's hard to really understand what you did and why you did it.
Right. So another thing I usually see in the works cited, especially in kind of the younger years or the kind of middle school area, is that sometimes I notice, I used to do this too, people just cite Google or Wikipedia or YouTube. And I think it's pretty important to know, especially at the middle school years, that we have formats for those, which is something that you can use to make your project look more professional, I guess.
Again, excellent point. I mean, I don't think there's anything wrong with looking at those sources just to give yourself some ideas and get you started. But that's a good point to not just cite Google. Like, even on Google, that'll lead you to different resources.
Right.
Cite the actual resource. I mean, important thing in science is actually to gear it, is to cite the proper reference, simply because that's really the basis from which you're working off of.
Right.
And even if you agree or disagree with their results or conclusions, it provides a clear line of being able to go back and verify or corroborate. So very important. And I know I tend to think a little bit too perhaps into what a future or a perfect project might look like, but in this case, perfection's not the goal. It's simply to really take the journey and learn how to do science along the way, because that's the important thing.
Right. So
and have fun with it. I mean, it's hopefully
you're
doing something you find very interesting.
So again, speaking of the journey, what would you say is some good advice to somebody who would like to progress to perhaps the national or even international level of science fairs?
I think part of that exercise might be to really become familiar with how the science fair is set up. So there, I know you're probably fully aware of what the scoring criteria is.
Right.
Just ask or go online. You can pull what the judges are using to judge you.
Yes.
And then you can use this kind of as a template or a guideline to say, well, am I hitting all the marks? And almost cross-reference what you have on your presentation. Is there a place that can be adjudicated on the scoring sheet, and really, trying to do the best you can to generate the higher marks.
Right.
That'll get you at least beyond the initial local or provincial stage, and then of course at the national stage, your competition's going to get a lot tighter, a lot harder, real quick.
Of course.
So then I think, aside from the presentation, really know your area, become comfortable with the material. And again, sometimes it's not about you, it's about the presentation. It's about your actual project, right? It's never a reflection on you. It's so really the star of the show becomes the project. So
that's true.
If you keep that in mind, then that'll hopefully help you to also not get nervous or anything, because really it's everyone's interested in the project. They're not looking at you, they're looking at what your work is. So I don't know if that's helpful or not.
Oh, I think it is.
I think everyone falls into that trap. So.
Right. Especially being nervous, I'd say just make it look like you're actually interested in what you're presenting. Like, don't worry too much about like a little stumble here or there. What's important is that at the end of the day, you're having fun presenting your project and helping the scientific community evolve.
Yeah, you probably, I think because you've actually experienced it, you probably have more advice to give your fellow students than I did, because I never reached that level as a young, let's say, scientist.
Well, it goes.
But we go through the same thing.
Yeah, it does go to show, though, that even if you don't end up going to international science fairs, national science fairs, all of that, you can still end up someplace great. So, looks like we're coming to the end of our time today, and with that, I'd like to thank you, Dr. Nykiforuk, for being here, and would like to ask if you have any advice to impart on our viewers or listeners.
I think again, I would keep up the great work. When you're tasked with something like being able to participate in a science fair, I would really just enjoy the experience and think about what you really want to do. I know they probably give you guidelines or different topics, and just think about it before you decide on landing on a single topic. Explore it a little bit so that you are to the point what you're saying earlier is that you're really enjoying presenting this. It's exciting to you, and stretch yourself, do something different or something that's always interested you or a question you've always had. And I think you'll enjoy the process a lot more.
All right. That sounds great. Thank you once again, Dr. Nykiforuk.
Yeah, you guys take care, and I hope to see you guys this year again at the Bison Regional Science Fair.
Hopefully.
And of course, have a few people go on to the nationals.
Of course. All right. Now, make sure to let us know what you guys think or any questions you might have down in the comments or on our socials at BRSF_MB on Instagram or at Bison Fair on Twitter. Don't forget to like and subscribe, and we'll see you next time here on STEMcasts. Bye-bye.